This is the second video on absolute value equations and inequalities, so we're actually going to not do any more equations. We're going to focus on inequalities from now on. So we want to focus on how do you solve an inequality that has absolute values in it. So here's the idea. So suppose x is a variable, and a is a non-negative real number, is a non-negative real number. So these are the kind we're going to be solving. You got to have a variable expression and then a non-negative real number. So number one, if you get an inequality like this, if you get something like the absolute value of an expression x, so that might not just be an x there. It could be like some other expression connected to an x, so a whole entire algebraic expression. But in any case, we're going to let x be a placeholder for a variable expression. Let's say that's less than or equal to a non-negative number. If you get something like that, then to solve this, what you do, you write the form x is less than a, and x is greater than negative a. So basically you stick x between a and negative a. Now let me show you how that works exactly. So I got what? Absolute value of x less than a. So I'm going to make two branches. So x is the variable, it's the unknown, right? So if you go back to the definition, x is greater than or equal to 0, then the absolute value of x is just x. So here you're going to get just x is less than a. Now, what if x were, for example, less than 0? What if x were negative? Well, if you go back to the definition, then the absolute value of x is minus x. So you get minus x is less than a. Now what you can do to that equation, you can multiply both sides by -1. When you multiply both sides by -1, you get x on this side. On the other side, you're going to get minus a. But you have to remember that the inequality flips direction when you multiply through by -1, so it turns around. So when you put these two together, these two inequalities together, you're going to have an x in the middle. X is going to be smaller than a, but x is also going to be bigger than negative a, so you can write it this way. X is bigger than negative a. And that's actually giving you that right there. Yeah, so that's where that little fact comes from. You don't have to remember this reconstruction, or this construction here. You don't have to remember this construction. I just wanted to show you where that came from. Yeah, so just remember, anytime you have the absolute value of x that's less than a, what you do, you write down an x, and then put inequalities where a is bigger than x and negative a is smaller than x. So x goes in the middle. X goes in between the negative a and the a. All right, here's a second situation. What if you get something that looks like this? If x is absolute value of x, my bad. What if you get the absolute value of x is bigger than a? So the other direction. Absolute value of x is bigger than a. Then you're going to break this up into x is greater than a, or x is less than negative a. So you break it up into two like that. So a different situation. Let me show you where this one comes from. So let's say I got the absolute value of x greater than a. So you got two cases, right? If x were non-negative, x is greater than or equal to 0, what happens? Well, you just copy down x, right? The absolute value of x is x, so you copy down the inequality, and then a. So x is greater than an a, okay. So that's this dude right here. The other case, what happens when x is less than 0 and x is negative? Well, according to the definition, the absolute value of x is minus x, or the opposite of x. So opposite of x greater than a. Now you don't like that negative in front of the x, so you multiply both sides by -1, and you get x is x on the left and minus a on the right. But what happens to inequality when you multiply by a -1? It flips. The inequality flips. So you get x is less than negative a. That's this guy right here. So yeah, that's where that comes from. Let me erase this. So just remember these two important facts when you're working with absolute value inequalities. It's two important facts. When the absolute value is less than something, when the absolute value is greater than something. So we're going to work a few inequalities. Exercises. We'll do 4 of these, I guess. Exercises. Solve the inequality. We're not going to actually have you graph your solution sets on the number line. If you want to, you can, but we're not going to ask that. You've already done that in a previous section, so I assume if you learned that skill in the previous section, we don't have to re-demonstrate it here. So here we go. Here's a number 1. We're just going to solve. Here I got the absolute value of x minus 3 plus 1 is less than 9. Okay, so your goal should always be to get the absolute value first by itself. Get the absolute value first by itself. So here I'm going to subtract 1 from both sides to get rid of that plus 1, right? That plus 1 is not within the absolute value. So we're going to subtract 1 from both sides. We're going to do the absolute value of x minus 3 is less than, what's 9 minus 1? 9 minus 1 is 8. Okay, so now we have the absolute value of x minus 3 is less than 8. So what case do we have? Do we have the absolute value is less than a number, or do we have the absolute value is greater than a number? We have case 1, right? Case 1. So in that case, what you're going to do, you're going to copy down what's inside your absolute value, which in this case is x minus 3. Then you're going to create an inequality, a compound inequality, where x minus 3 is in the middle. X minus 3 is going to be less than 8. And x minus 3 is going to be greater than negative 8. So you always take what's in the absolute value and put it in the middle. All right, so now we have to solve this compound inequality. So basically to solve this, you got to get the x by itself here in the middle. How do you get x by itself in the middle? Well, you're going to have to get rid of that minus 3 in the middle, right? So I'm going to add 3. So if I added 3 in the middle, I got to add 3 on the left, and I got to add 3 on the far right. So let's do that. Let's add 3 to everything here. So what's negative 8 plus 3? Negative 8 plus 3 is negative 5. Then I have the less than symbol. Negative 3 and positive 3 cancel in the middle, so I just have x in the middle. And then I got the less than symbol, and then I got 8 plus 3 on the far right. 8 plus 3 is 11. So here we have that x is in between negative 5 and 11. In order for this to be a true inequality, x must be between negative 5 and 11. All right, so x is less than 5, x is bigger than, x is less than 11, but x is greater than negative 5. All right, so number 2. Here we have, what do we have? 2, absolute value, x plus 2, close the absolute value, plus 3, less than or equal to 23. Okay, so the idea is you want to get the absolute value by itself. Is the absolute value by itself on the left side? No. So first we're going to subtract the 3 from both sides. So we want to get rid of that plus 3, so we subtract 3. So that's going to give us 2, absolute value, x plus 2, close the absolute value, less than or equal to 23 minus 3, 20. All right, so the absolute value is still not by itself, so we got to get rid of that 2 out in front. So let's divide both sides by 2. Here the 2's are going to cancel. We're going to get the absolute value of x plus 2 less than or equal to 20 over 2 is, 20 divided by 2 is 10. All right, so okay, so we got the absolute value. We got the absolute value by itself. Which case are we talking about? Are we talking about a case 1 or case 2? Do we have the absolute value less than, or do we have the absolute value greater than? This is a less than situation. Actually, it's less than or equal to, but it's pretty much the same thing as the less than. So again, it's a case 1 situation. So what I'm going to do, I'm going to take x plus 2 and write it down. And then I'm going to take this symbol, make x plus 2 less than or equal to 10. I'm going to make x plus 2 greater than or equal to negative 10. So x plus 2 goes in the middle when you got the less than type situation. All right, so now I just got to get the x by itself in the middle. What's keeping x from being by itself? Well, plus 2, so we got to subtract 2 there in the middle. If you subtract 2 in the middle, you got to subtract 2 on the far left, subtract 2 on the far right. And what are we going to have on the far left? Well, negative 10 and negative 2 is negative 12. We got the inequality less than or equal to. 2 and negative 2 cancel in the middle, so we got an x. We got the less than or equal to sign, and then 10 minus 2 is 8. So in order for this inequality to be true, you have to pick a number x between negative 12 and 8, or it could be equal to negative 12 or equal to 8. All right, number 3. Another inequality here. Here we got 3, absolute value of x plus 5. Close the absolute value. Minus 1 equals 20. No, greater than 20, my bad. Greater than 20, not equals. Greater than 20. So, is the absolute value by itself, first of all? That's the first question you ask. You say, no, it's not. So I'm going to add 1 to both sides to get rid of that minus. What I'm going to have 3, absolute value of x plus 5, greater than 21. Is the absolute value by itself? No, you got to get rid of that 3 out front. Multiplication by 3. So undo it by dividing both sides by 3. Divide the left side by 3 and you get x plus 5 greater than, divide the right side by 3, 23 over 3, 23 by 3 is 7. All right, so we got the absolute value by itself. Now that it's by itself, is it a case 1 or case 2? Case 1 or case 2? It's case 2. It's a greater than situation, right? It's a greater than situation. Absolute value is greater than. So what you do, you set x plus 5 and break it into 2, right? You take x plus 5, what's under the radical, greater than 7, and also you set x plus 5, what's under the, what did I say, radical, absolute value. What's under the absolute value? You take what's under the absolute value, x plus 5, and set it less than negative 7. So for the first situation, we're going to subtract 5 from both sides. We're going to get x is greater than 2. In the second situation, we're going to subtract 5 from both sides, and we're going to get x is less than negative 12. Okay, so in order for this inequality to be true, you have to pick a number. Should be less than, right? Less than. I don't know why I wrote equal to, less than. You have to pick either a number greater than 2, or you have to pick a number less than negative 12. So if you pick a number greater than 2, it'll work out fine. If you pick a number less than negative 12, it'll work out fine. Either situation. All right, here's my final problem. I'm just going to do a number 4 here. Inequality with absolute value. So you got the absolute value, 4x minus 1 over 5. Close the absolute value, that's greater than or equal to 3. So I have the absolute value by itself already. Hey, that's nice. So as soon as you have the absolute value by itself and you notice it's an inequality, you have to figure out, is it the greater than case or is it the less than case? Is it the less than case or is it the greater than case? Well, this is a greater than type. It's actually greater than or equal to. So you're going to treat it like the greater than case. So when this happens, you're going to take what's under your absolute value. Then you're going to make 2 cases. Take what's under your absolute value, 4x minus 1 over 5. set that one greater than or equal to 3. It's the first branch. And the second branch, you're going to take what's under your absolute value, 4x minus 1, over 5, and you're going to make that less than or equal to negative 3. So these are basic inequalities. To solve these, we're going to multiply both sides by 5 to get rid of the 5 on bottom. Multiply both sides by 5. It's 5 over 1. You can think of it that way. The 5 on top cancels with the 5 on bottom there on the left side, and you get 4x minus 1 greater than or equal to what? 5 times 3 is 15. So to solve this now, I would add 1 to each side, and I get 4x greater than or equal to 16. And then from here, divide both sides by 4. And the 4s would cancel. I get x by itself is greater than or equal to 16 over 4. 16 divided by 4 is 4. So x is greater than or equal to 4. On the other branch, the other inequality that resulted, we do almost the same thing. We multiply both sides by 5. It's 5 over 1. Here the 5s will cancel. You get 4x minus 1 on the left is less than or equal to 5 times negative 3 is negative 15. You would add a 1 to each side. You get 4x is, in this case, less than or equal to negative 15 plus 1 is negative 14, and then from here you would get rid of the 4 in front of the x by dividing both sides by 4. You get the 4's cancel. Yep, the 4's cancel. You get the x on the left is less than or equal to negative 14 over 4. Well, that doesn't come out nice, but you can reduce it, right? You can divide the top and the bottom by 2. Divide out a 2 in common, you get negative 7 halves. Or you could write negative 3.5, that'd be fine as well. All right, so that's it. Solving absolute value inequalities.